Hello everyone, this is Debabrata here. Welcome to Schrodinger's cat. And basically, in our previous lecture, today we just discussed the unit dimension and error from class 11. And today we will discuss the electrostatics from class 12 and cover the topics the electric charges and the fields, electric charges and Coulomb law, electric field, electric dipole, continuous charge distribution, electric flux and Gauss law. Second one, the electrostatic potential and equipotential surface, electrostatic potential and equipotential surface, electric dipole and potential energy, capacitor and its capacitance, combinations of capacitors and energy stored in the capacitor. And today the total number of questions coming in the entrance exam in these chapters in the NEET exam, there are 3 questions, JEE Main 4 to 5 and the advance 5 questions are come in these chapters. And one thing is that basically for the exam point of view, we just discussed here the chapters summary in a nutshell and do some previous year problem coming in NEET, JEE Main and advance. And after covering all the topics, we just elaborately deduce all the theory. Let's get started. First of one is the electric field and the potential. So finally, that the electric field and the potential, that first one is that the Coulomb's law or force acting between two charged particles is given by the F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square, or it is written as in SI format 9.0 into 10 to the power 9 Q1 Q2 divided by R square in Newton. And the second one is that the Coulomb law in the vector form, basically this is Coulomb law in the vector form. So this is the coordinate and this is the A plus Q1 charge and the B plus Q2 charge. This is R1 and this is R2. This is origin here. So basically the force on charge B basically is defined as the F BA is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So R1 minus R2 mod square into R cap. R cap basically the unit vector. So R1 minus R2 divided by mod of R1 minus R2. So second one is the basically electric field due to a point charge. So this is charge plus Q and the electric field, this is minus Q here, and suppose for the point charge plus Q, the electric field here E, this is OP and this is R. So electric field is defined as the E 1 by 4 pi epsilon naught Q by R square Newton per Coulomb. And the third one, the electric field at the point on the axis of a uniformly charged ring. Basically, this is a ring, charged ring, and we have to find the electric field at this point P, is basically formally written as F 1 by 4 pi epsilon naught Qx is divided by a square plus x square to the power 3 by 2, where this is the A and the x is this distance, this is the R. And if P is situated very far from the center of the ring, for x greater than A, we just write E equal to 1 by 4 pi epsilon naught Q by x square. So fourth one is the electrical potential. So the potential at point due to a point charge is defined as V 1 by 4 pi epsilon naught Q by R volt. And for the negative charge, minus Q, for the negative charge minus Q, this is written in the form of, just take minus sign here, so V equal to minus 1 by 4 pi epsilon naught Q by R. So one thing is that electrical potential at a point because of system of charge. Now for the system of charge, that suppose the distance is R1, R2, R3 and R4 for the charge plus Q1 minus Q2 minus Q3 plus Q4 is V equal to total potential V1 plus V2 plus V3 plus V4 is equal to 1 by 4 pi epsilon naught Q1 by R1 minus Q2 by R2 minus Q3 by R3 plus Q4 by R4. Now relation between electric field and the potential gradient. So electric field E equal to minus del V del x, it is also written as minus dV dx. This is volt per meter, and the dV dx is defined as the potential gradient. This is called the potential gradient. And for intensity of the electric field, here E is equal to V1 minus V2 divided by D. Basically for this is V1 potential and the V2, and here D is the distance between here, and these are the plus charge and the minus charge. And another thing is that now if electric potential of particle is defined by some function, here suppose the function here potential of xyz, so minus del v del x is equal to ex and minus del v del y is equal to ui minus del v del z equal to ez when derivative keeping xy constant. So electric potential energy of two charge system is defined as electric potential of two charge system. Suppose this is Q1 charge and this is here the plus Q2 charge. So infinity to bring out one charge here. This is point A and the B. This distance is R. So the electrical potential energy U is defined as 1 by 4 pi epsilon naught Q1 Q2 divided by R. This is in the unit of joule. Now electric potential energy for more than two system of charge. Suppose this is a triangle here and the 3-point charge Q1 minus Q2 and the Q3. This is R12, R23, R13. So now U is equal to 1 by 4 pi epsilon naught minus Q1 Q2 by R12, Q2 Q3 by R23 plus Q1 Q3 by R13. Now work done in charging configuration of charge slowly. So basically the work done for del kinetic energy is equal to 0. The W external is equal to U final minus U initial. Basically W E is equal to UF minus UI. Now work done in moving charge. Work done in moving charge is equal to W external is equal to Q into V. So V initial minus V final. W equal to QV. Now the electric dipole moment, and for this is a dipole minus Q charge here and the plus Q, and the distance is 12, and here the electric field direction opposite to dipole moment P. So P equal to Q charge cross 2L, basically 2QL. Direction of P is opposite of E between the charges, and the torque acting on a dipole in a uniform electric field. Suppose this is a dipole making angle with theta. This is charge plus Q and the minus Q, and this is the 2L distance. So electric field here, force acting F is equal to QE, and here is a force, and the electric field direction is the injection. So torque tau, basically QE cos 2L sin theta. And this is equal to PE sin theta and the tau P cross E. Tau equal to P cross E, and the work done in rotating a dipole placed in uniform electric field. Suppose the alpha is theta 1 and the another one alpha dash is theta 2. So work done would be W equal to PE cos theta 1 minus cos theta 2. This is basically the work done, and the potential energy of a dipole placed in electric field with angle theta. The potential energy U theta minus PE cos theta is minus P dot E. This is the potential energy. And another thing is that the electric field at point on the axis. So electric field point on the axis is defined as the, suppose the electric field here, this is two dipole minus q and plus q, and for the field acting here, the E1 in this direction and E2 in this direction, and the distance between this is origin and this is, we have to find the electric dipole, the distance is r. So basically here E is equal to 1 by 4 pi epsilon 2p by r cube Newton per Coulomb. This is basically end on position, point on the axis, and potential at point on the axis of dipole at distance r. Here this is basically the end on position, and the potential become here V equal to 1 by 4 pi epsilon P by R square volt. And for the broadside position, so basically this is would become, this is minus q charge and the plus q charge. This is a point P. So basically here this is electric field in these directions E1, and this is the E2. So resultant electric field would be in this direction E. So basically you have to find this one. And this is basically the distance theta and L, this distance. So in this position the electric field would become E equal to 1 by 4 pi epsilon naught P by R cube Newton per Coulomb, and the potential here V equal to V1 plus V2, and basically K q by root over r square plus L square, this distance, this is root over r square plus L square, and minus K cancel out, just root over r square plus L square. So this is become 0. Potential here is 0. And another last one, that the at general point r making theta. So basically this is the dipole, minus q here plus q, general this is, and this is angle theta here, and this point P. So we have to find, suppose we think this is the angle delta, so EP would become 1 by 4 pi epsilon naught P by R cube root over 3 cos square theta plus 1, and the delta angle between dipole tan inverse tan theta by 2, and the potential in this point P, Vp is 1 by 4 pi epsilon naught P cos theta by R square. So this is all the formula of electric field and dipole. Now go ahead, our second topic, the Gauss law. So basically first one is the Gauss theorem. Basically we have to deduce one thing, is that solid angle omega, solid angle is defined as the del A area by R square at steradian. This is the solid angle d omega dA cos theta by R square, dA cos theta by R square. And electric flux, so total area, the electric flux, so total area is phi E equal to EdA. This is elementary area dA, and the electric field here, these directions. And suppose it's made an angle theta here. So for that case, phi E is equal to EA cos theta. And the Gauss theorem states that the flux phi E of the net electric field through a closed surface A equal to the net charge enclosed by surface divided by epsilon. Basically, the integration over A E dot dA, Gauss theorem states that Q by epsilon naught. Basically, the electric flux phi E is equal to Q 1 by epsilon is equal to Q by epsilon naught. Suppose if a closed surface area A contains charges Q1, Q2, Q3 and Q4. Suppose Q1, Q2 minus Q3 and the Q4. So the total flux phi E is equal to Q1 by epsilon naught plus Q2 by epsilon naught minus Q3 by epsilon naught plus Q4 by epsilon naught is equal to 1 by epsilon naught sum over Q. So electric field due to a uniformly charged spherical shell. For the charged spherical shell, this is a shell, so r distance, and the electric field in the point P, and this and the surface charge density sigma here, Q by A is equal to Q by A means 4 pi r square. Here this is r, and the electric field here E 1 by 4 pi epsilon Q by r square when r greater than capital R, and sigma by epsilon naught when r is equal to capital R, and E0 when r less than capital R. See conditions here, and the graph would like be, this is the R origin electric field E, so this one basically proportional to 1 by r square. And now the electric potential due to a uniformly charged sphere, this is field, and the potential V is equal to 1 by 4 pi epsilon naught Q by R when R is greater than capital R. Basically here R is distance, this is R, and this R is radius, and this would become the 1 by 4 pi epsilon naught Q by R when R less than equal to capital R, and the graph would like become, this is R origin and the potential V, this is capital R point, and this one, this is proportional to 1 by R. So now go ahead, the electric field intensity due to a uniformly charged non-conducting sphere. This is very important for the non-conducting case. For the electric field intensity non-conducting sphere, for the non-conducting sphere, one thing is that this is non-conducting sphere and this is R origin and this point is P, this is electric field direction E, this is R. So now electric field intensity E would become that 1 by 4 pi epsilon naught Q by R square when R greater than capital R, and 1 by 4 pi epsilon naught Q by capital R square when R is capital R. So in general, third one is most important coming in entrance exam. I think one time coming in IIT exam 1 by 4 pi epsilon naught Q R by capital R cube. This is for R less than capital R. So here the Q charge put 4/3 pi R cube rho and the electric field rho by epsilon naught R by 3 and E proportional to 1 by R square when R greater than capital R, and proportional to R, E proportional to R, this is important case when R less than R, and the graph would become, so this is proportional to 1 by R square and symmetry this one. So R is origin R and the electric field this one. So potential in non-conducting spherical cell, this is the electric field. Now we have to find the potential. So the potential case, the Q by 4 pi epsilon naught 1 by R when R greater than equal to capital R, and Q by 8 pi epsilon naught R cube C R square minus R square when R less than capital R. And at the center of the sphere, now the V center is equal to CQ by 8 pi epsilon naught R. So basically the V center is equal to C by 2 of V surface. So the graph would become, this is the R and the potential V. So graph is this one, and this bending point here, this is the R point, R naught, and this first one is V surface center and this is the V surface. So now second one is that the electric field and potential formula for solid metallic sphere is same as given the spherical shell. And one thing is that electric field due to a linear charge distribution. So linear charge distribution, this is a cylinder. So here this point is E, electric field, and we have to find the electric field at this point P. So linear charge density is lambda. So E would become lambda by 2 pi epsilon naught R, 2 pi epsilon naught R, where lambda is linear charge density and the electric field due to a plane sheet of charge, this plane sheet of charge, So for plane sheet of charge, the phi E is equal to sigma A by epsilon naught. So basically the electric field here is sigma by 2 epsilon naught. Sigma by 2 epsilon naught. And electric field intensity just outside the charge conductor. Electric field intensity just outside the charge conductor. This is a charge conductor. This is sheet 1 and sheet 2. Here charge positive. This is charge negative and sigma here. So we have to find the electric field at this point. So E1 and the E2. So basically total electric field is equal to E1 plus E2 is equal to sigma by 2 epsilon naught for the charge sheet and the sigma by 2 epsilon naught 2 sheet. So sigma by 2 epsilon naught. So finally for the charge conductor E equal to sigma by epsilon naught. Equal to sigma by epsilon naught. E is equal to sigma by epsilon naught. So now one thing is that the relationship between the intensity of electric field and potential due to parallel and opposite non-conducting sheet. So last one is that for the non-conducting sheet, so this is a sheet here and this is a sheet. So this potential is V. This is sheet A and sheet B. Here the positive charge and here the negative one. So this is the distance D. So basically, so first of one, the electric field between two plate. The electric field between two plate, you know, the sigma by epsilon naught, and electric field outside the plate. So here the outside the plate, this is the E1 and E2 here, and the inside both are in the same direction, E1 and the E2. So E, this is equal to E1 minus E2 is equal to 0. So potential difference, we know the E equal to V by R, here the distance D, and E is equal to sigma by epsilon naught. So V by D is equal to sigma by epsilon naught. Our final relation between the potential difference V equal to sigma D by epsilon naught. Sigma D by epsilon naught. So our next chapter is the capacitors. For the capacitors, first one, the capacitance of the conductor is defined the C equal to Q by V. Unit of capacitance, Coulomb per volt, or this is written as farad. Capacity of an isolated spherical conductor, C equal to Q by V, is basically C equal to, it basically I just put a line here for a better understanding. C equal to 4 pi epsilon naught Kr. If K equal to 1, the C equal to 4 pi epsilon naught R. Now potential energy of a charged conductor, the potential energy U equal to half QV is equal to half CV square is equal to Q square by 2C in joule, and the energy density small u is potential energy by volume. So half, this formula is important, epsilon naught E square. This is the joule per meter cube, the energy density. Now the capacitance of parallel plate capacitor C naught K epsilon naught A by D, where A is the area, so C is proportional to A, proportional to 1 by D and proportional to K. So if in the medium K equal to 1, if, so now C naught equal to epsilon naught A by D. Now capacity of parallel plate capacitor with filled with dielectric substance, this is important. So this is a plate P1 and this is the another plate P2, this is the another plate P2, P1 and the P2. So this distance is D and now earthing here, and this is the dielectric field. So this is the plus charge, plus Q, and this is the minus Q. This thickness is T and the dielectric medium is K. So now C equal to epsilon naught A by D minus T plus T by K. K be the dielectric constant. Special condition. Now, so if capacitor is completely filled with dielectric, this is important for the special condition, filled with dielectric completely. So T equal to D. Now C equal to K epsilon naught A by D. Capacitor is containing air only, so T equal to 0 and the C would become epsilon naught A by D. Third one, if metal plate of thickness T is placed between the plate, now K should be infinity and the capacitance would become that the epsilon, you just K infinity put epsilon naught A D minus T. And now one thing, this is very important for your entrance exam purpose. So K1, K2, K3 dot 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 Kn dielectric is placed of thickness T1, T2 and T3. Basically that this is one plate, 2, 3, 4. This is K1, K2 and the K3 plus Q naught minus Q naught. So in general C would become the epsilon naught A divided by, so here dot dot the Kn term, Kn dielectric, and the T would become, this is T1, T2, T3 dot 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 Tn. So for this case, that D minus T1 plus dot 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 plus T1 by K1 plus dot dot Tn by Kn. This is dot 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 plus Tn. And another thing is that for the magnitude of induced charge magnitude of induced charge. So magnitude of induced charge, that Q dash is equal to Q 1 minus 1 by K. Sigma dash is equal to sigma 1 minus 1 by K. Parallel plate capacitor attract with force. The force F is equal to Q square by 2 epsilon naught. And for the spherical capacitor, the capacitance would become 4 pi epsilon naught K, inner radius A, outer radius B, B minus A. And another one for the cylindrical capacitor. This is for the cylindrical capacitor. Capacitance would be 2 pi epsilon naught L, ln B by A. Inner radius A, outer radius B. And another one, capacitor connected in series. So 1 by CS, 1 by C1 plus 1 by C2 plus dot dot 1 by Cn. Connecting in parallel, so Cp is equal to C1 plus C2 dot dot Cn. Reverse of resistance. Now charging of capacitor through resistance. This is important. Charging of capacitor through resistance. So Q is equal to Q naught 1 minus exponential minus T by CR, time constant. So basically here the I current would become I naught e to the power minus T by CR, where the I naught is equal to Q naught by CR. So the graph, this is the time and the charge Q, this one for the charging, and for the discharging, so Q is equal to Q naught e to the power minus T by CR. So for discharging, that this one T and this one the Q, this is time constant CR. So last one is that the conducting sphere connected to each other. Basically sigma 1 sigma 2, charge density of two sphere. So sigma 1 by sigma 2 is equal to reverse of the diameter R2 by R1. This is basically a sphere connected spheres. Q1 charge, Q2, just connect here, and the R1, this is for the R2, and sigma 1 sigma 2, basically sigma proportional to 1 by R. So we just conclude here our chapter summary in a nutshell. Now we go ahead our problem discussion sessions. First one is coming in JEE Advanced. Basically it's saying that an electric dipole is formed by two charges plus Q and minus Q located in the XY plane. And now basically the point 0, 2 and 0 minus 2 millimeter. Now the electric potential at point P here is given 100 millimeter due to dipole is V0 here. Now the charges plus Q and minus Q are then moved to the point minus 1, 2. This is point, the moved minus 1, 2 and 1 minus 2. This is moved the charge. What is the value of the electric potential at the point P due to a new dipole? Basically here given a dipole P in this point, we have to find the electric potential in this point P, Vp, coming in 2023 JEE Advanced. So here that just draw, this is the x and the y. So this point is P and R, this is the 45 origin and this is the P naught and this is the R. We have to move point this charge. So for case 1, that V naught is equal to K P naught by R square into cos theta, here given cos 45 degree, and the case 2, basically component of P naught dash, here this is P naught and this is the P naught dash, the component of P naught dash along x axis is minus P naught by 2I, this is component, and for the y axis this component would become P naught J. Now potential due to P naught J, this point, potential due to P naught J, basically the K P naught cos theta or cos 45 degree by R square, this is equal to V naught given, and potential due to minus P naught by 2I, this is the V naught by 2. So basically we have to find the potential at point P in the new dipole. Basically this is P, so we have to find the potential here P dashed. So this would become our final answer, that V naught by 2, this is V naught, and for P naught I, this is basically the reverse, so V is half of the potential of the P naught J, so basically our final is P naught by 2, basically B would be our correct answer. Second one coming is NEET 2020, saying that a parallel plate capacitor having cross sectional area A and separation D has air in between the plates. You just pause this video and read all the questions for your better concepts and thinking the answers. But thickness is D by 2, inserted plate shown in the figure. Basically parallel plate capacitor and slab thickness D by 2 is inserted between this, which the dielectric constant is K. You have to find the capacitance of original. So we just write a one formula in our chapter summary in a nutshell, that C is equal to epsilon naught A D minus T plus T by K, this is formula. So for C naught, epsilon A by D, first one, and here given the A dash is A and the thickness is D by 2 and the dielectric constant is K. So just put this value, epsilon A divided by D minus T plus T by K, which is equal to epsilon naught A divided by D, T would be the D by 2 and T would be the D by 2 and K would be 4. You just calculate and it would become 8 by 5 epsilon A by D. So now you just find the ratio C by C naught. So 8 by 5 epsilon A by D, and this one the original epsilon naught A by D, so it would become 8 by 5. So C by C naught is equal to 8:5. So 8:5, B would be our correct answer. Third one coming is NET recent questions 2023 is saying that if E dot ds over a surface is equal to 0. So which would be our correct answer? Basically here one thing is that according to Gauss law, that E dot ds represent the electric flux passing through a closed surface. Now this is would be 0, flux phi 0 in the given question. So it signifies that number of electric line entering the surface, number of electric flux line entering the surface must be equal to the number of flux line leaving it. Basically this is entering phi e is equal to phi left. So D would be our correct answers. Theoretical questions, conceptual, coming in NEET exam. Now fourth one is NEET 2023 saying that the equivalent capacitance of the systems. So basically you have to know that for parallel plate capacitor Cp is just series one C1 and C2 sum. So here the AB parallel CAB is equal to, like basically this 3 and 3. So 3 into 3 plus 3 by 3 plus 3 plus 3. I just that one thing is that this is a these two, one is in here the current is difference, so parallel, so 3 plus 3, and this is in series CS and CP. So 18 by 9, 2 microfarad. So basically D would be our correct answer. Last one coming in JEE Main 2019. So this is another important questions, is saying that a parallel plate capacitor made of two square plate side A separated by distance D at the lower triangular portion filled with the dielectric constant K as shown in the figure. You have to find the capacitance. So basically here we have to, one thing is that we just consider a small strip dx. This is the dx and this is the point x. So this is the y, x dx, this x and dx, and this is the y. So basically here this is d. So slope m would be the slope, y by x is equal to d by a. So y equal to d by a into x. This is equation number 1. Now capacitance of a small portion C is equal to integration of small element dc is equal to integration epsilon naught a dx is divided by d minus y plus y by k. We just write this formula, d minus t plus y. This is equation number 2. Now comparing equation 1 and 2, comparing, we get that C is equal to epsilon naught a 0 to a integration dx divided by d plus dx by a 1 plus 1 by k minus 1. So you just do this integration, simply just integration of dx by x, basically the ln x, integration dx by x ln x. So just and the put in the upper limit, you just get the epsilon naught a square k divided by d into k minus 1 and the ln k. So I think B would be our correct answer, k epsilon naught a square, k epsilon naught a square by d into k minus 1 ln k. B would be our correct answer. So we just do 5 problems in NEET and JEE Main. For your better concept and understanding, I just get usually for the questions for your homework, you just pause this video and take a screenshot these 5 questions. So I think you just take a screenshot. So now I just cover here the 10 questions, 5 the practice and 5 for your homework, and I think you just do all the questions from the electrostatics, 3 chapters here, field, potential, Gauss Law and the capacitors. So finally, last but not the least, solve this homework. If anyone need this file like the study materials on my YouTube lecture, just mail without no hesitations in the cat Schrödinger's 1935@gmail.com. Thank you very much. Stay happy and well. Have a good day.